I've got a foundational soft check tool up on my screen here. Just pulled just a blank piece of code in. First thing I've done is I've changed my fail mode, the option to remeasure or back up. I've gone down and I've added my CSV out and my saved drawing file. So now I am ready to start coding. What I have here is some speakers that I was doing a measurement session to, and I just had a room full of them. That client actually wanted to put the speaker into an alignment and then look at some dimensions on the front face of this as a package opening based on the datums that were on the part. So what I've got is a very simplistic 3-2-1 alignment, but what I'd like to do is go through and explain to you the difference between online learn and what I call debug. Online learn gives you guys the ability here, if you're hooked up to an ARM or a laser tracker, you can click on the online learn icon up here, and what it does is it will allow you just to start measuring the part as if you were in just a regular SAT file. What I've found out though is when you get done with the whole measurement session, the SAT file from that session does not get saved. So you'll have to run through that program again and save that as your first part. What I like to stress though is to do just programming here in this session by not being attached to an ARM or a tracker, just because what I like to promote is at debug time, or once you get your part, or once you get your ARM, that you will start to go through your code line by line there when you get to your measurement session. Because right now I don't have an ARM attached to my laptop. I'm not ready for the measurement session. I'm not at my client's place. I don't have a CAD model, and I wasn't going to use one for this program, but say you had to wait for your CAD program. None of those issues should stop you from coding your soft check tool or your learn execute. So what I promote is not the online learn, but what I call debug. So I'm just going to do a basic couple steps here just to show you what I would do prior to getting to this manufacturer that makes these speakers. What I'd like to do is get right down here to line number 8, since when I start coding, I will start dropping in code above the line that I've got highlighted. Well, the first thing I wanted to do was measure a plane on the bottom of this part. So what I'm going to do is say measure a plane. Now notice that it just took and populated this line 8 with a measure plane. It's defaulting to Faro's designated name for planes. It's just calling it a measured plane 001. The next steps that I do here, I do on 100% of my code, and this is personal preference, but I found it to be very repeatable for me when I'm coding, so it makes it a little bit more efficient. Once I drop that measure plane into this section, I highlight it, I automatically go and change the name. And I do that in measurement sessions as well. I change the name right off the bat. I'm just going to call that the datum A plane. And then what I do is I start following these lines of code from top to bottom. And then what I'll do first is I will change the comment for point 1. What these comments do is this will tell me when I run the code, it will show up with a picture and this comment to tell me where I've got to go next with my arm to take the measurement. So I like that description there to start with this measure, point 1 on plane. Now I double clicked it to get to this spot. And this is what I do on every piece of code. I'll go to the end of the line, enter, enter, put cap locks on, and then I write my description, something like this. This plane defines the datum A surface using 6 points. And then down here, you can't see it on my screen so much, but I'll say OK. Now notice what it's done is I'll open this up just a little bit more. My label for datum A plane, since I've changed that up in the corner here for my label, it's populated my label column. But my comment now is in here. This plane defines the datum A surface, and there will be a picture associated with that, which I'll go through in a later module. But when I hit this line of code for measuring a plane, this comment will be the first comment that I see, and it's comment for point 1. Well, in my comment, I mentioned that I'm going to put 6 points on. So that's the next thing I do. I run down to the points on feature, double click on that, and I change the points on feature to 6. Or if you're using 8, go ahead and plug in 8 for that one, and I say OK. Now notice what it's done is it's added some other lines of code where I could put comments in for this datum A plane. But what I do is I only put the comment on the first point that I'm taking on this plane. And I will show you why in the module that goes through actual measurement of a soft check tool or running through a soft check tool. But then what I do is I'll come down, I'll display the results, double click twice to display the results on. And then if this was a datum, I will run down to the bottom right hand corner and say that this is datum, and I'll assign the feature here as datum A. So I'll enable the box here and say OK. So now I've actually got a datum A plane that I've measured with 6 points on it. Now I'll go down to the next line of code. I'll highlight just below because every line of code will get populated above my highlighted line. Now I'm going to do a measure, slot, round slot. Because the features that they're using to locate this in the sheet metal on a vehicle are slots, so the datum pins on the part are actually slotted features. So since a slot is a 2D feature, you have to select a plane that will be used to define that slot. So what I've got here, if I use my down arrow, sure enough, there's my datum A plane. And I don't have an offset for it, so I'll say OK. Then I'll go back up, I'll highlight that line of code that I just dropped into there. And I'm going to change that name. I'll call that datum B slot. And I'll enter that. I run down to the arc for point 1. Double click on that. Comes up with the comment. I do the same thing with a comment. I go to the end of the line, enter, enter. Cap locks is still on, so I would say this round slot defines datum B. And I might say that it's a pin on right side of speaker. And then I will say OK. What I do like to do is make my comments pretty explicit so there's no question about what side of the part I'm measuring to or what the feature is that I'm actually measuring here. So what I've got is this right here. I've got the comment that I've put in here for these 3 points on the arc of one side of the pin. These 3 points on the other side of the pin don't have a comment, or these don't have comments. Only the first point that I'm going to encounter when the pictures come up. Then I do the display results. I'd like to see that. I'll turn that on. And then I look down here and say, yep, the plane that it's defining to is my datum A plane. Okay, I like that. I'm not going to worry about the tolerancing right now or associating a nominal since I don't have that out there. Now, here's the trick. Is I could take my datum B slot. I'm going to measure one more slot pin just like this one. So I am going to right mouse key, copy that whole line of code, and then I'm going to highlight just below it, and then I'm going to right mouse key, paste. Now look at this. Okay, so if I highlight this datum B slot, notice what it's done. Faro automatically increased the number. It thinks it's going to be another slot in the sequence here, so it called it B slot 001. So it's added these 3 numbers behind the datum B slot. So I don't like that. I'll get rid of those 3 because this for me is the datum C slot. So I've changed the name on that. I run down to the comment here for point 1. I'll double click on that and I'll change the comment to say that this is actually datum C and it's the pin on the left side of the speaker. And then I say OK. Now I've got a datum C slot that's put right below my datum B. And if I wanted to, I could take this datum B slot, make him a datum, clicking on this icon lower right, and then change it to B by checking in that box. And I say OK to that. C, maybe that's my datum C. Why would I name it anything different? Of course. OK. Datum C. Now, I've got some datums associated to those, and then I've got these 3 features that are going to be used for my alignment. Now, what I'd like to promote is getting into my alignment or my coordinate system as quick as I can. So I've got my features measured already that I'm going to use for my coordinate system. And I'm going to go down to the next line of code here, highlight that, and then I'm going to construct my coordinate system. It's a 3, 2, 1. Very simple coordinate system just to get me into alignment here where my dimensions will come out, and that'll be squared to the grid or the drawing that I've got. So what I've got here is select a plane. I don't like that. I want to go to the datum A plane. In this situation, though, the datum C slot and the datum B slot are put on the same plane as what datum A is. So I will just click that, though, just for clean programming. And the direction of the plane for X, Y, I'm fine with that. But now what I'd like to do is click on this radio button here and say that my point on the axis for X, I want it to start at B and then go through C. But then what I want is the origin to go through B. So that's my constructed coordinate system. And if you haven't seen or played in the modules that describe all the coordinate systems, how to construct them and how to manipulate those, go back to those too. Very good stuff to be able to put a coordinate system onto your part. And I promote doing that fairly early in your measurement session. So I'm going to say OK to that. And now I've got my coordinate system inside of my soft check tool. It says it's a coordinate system. That's a 3, 2, 1. Got coordsys as a label. That's the Faro default label that they've given it. I might change that label and call that coordsys ABC. The reason I do that is in some situations I've got multiple coordinate systems, maybe to some subdatums. That would be a DEF. Or what I've done is on a machine, I've measured a coordinate system, and what I've done is manipulated the datum pins maybe, or the datum pads. Maybe I've added some shims to them to tune the machine. Well, then I'll construct another coordinate system that would be coordsys datums after shims, or coordsys with shims, or something like that. So I always give my coordinate systems a name as well. Now I go to the very next line of code again, and I say, after my coordinate system, I want to do my alignment. My CAD equals part. Now I don't have a CAD part at all, so what I want to do here is I want to fake out the arm. I want to tell the arm coordinate system to jump into the coordinate system that I just constructed there on ABC. So I'll say OK to that. And there I have it. And again, I changed the alignment name as well to match the coordinate system name. So I'm going to call that my alignment ABC. Then I'm going to highlight the next line of code. So I've added some datum features, I've added some coordinate systems here, and then I've got some export out items here, the data as well as the SCT file. So what I would do now is if I had the part attached to my fixture or located here in the lab, I would quick do an alignment debug, or I would run through the code with the part just to make sure that my alignment actually worked. This is a very simplistic alignment, so this one isn't so bad. But when I start aligning to CAD models where I've got compound angles and multiple features that are holding onto my parts, then what I would do is probably debug the alignment by itself before I started measuring and getting into the measurement session. But here this is a very simplistic alignment, so what I could do is just keep coding beneath the alignment ABC here to the features on the drawing. But I'm going to hold off on that right now, and I'll get into another module here that's going to explain more about how to add multiple features after your alignment. So stick around for that one too.